All right, guys, so we are going to be talking about seasons and what seasons are. Hopefully you know the order of the seasons. Okay, so right now we are in winter. The next season is spring, and then summer, and then fall. Okay, we are also going to be learning some different vocabulary that maybe you have not learned before. So a season is a regular change in temperature that repeats itself every year. Okay, when you're looking at the Earth, it is divided by the equator, which is in the center. A hemisphere is going to be where it divides. So it's half of the Earth. The top is in the northern hemisphere. The bottom is in the southern hemisphere. We are located in the northern hemisphere, so we're over here. Okay, and so everything, when you talk about seasons, you need to think, okay, we're in the northern hemisphere. That will help you when determining what season it is in the southern hemisphere. The axis on the Earth is an imaginary line, okay, it's not actually there, that the Earth spins on. So if you look right here, the axis is tilted. So you can tell it's not straight up and down, it is tilted to one side, and it spins on its axis, causing day and night. So it makes one spin all the way around in 24 hours. So that's why we have daytime, and that's why we have nighttime. And also, as you can see, the equator is going right in the middle. The axis is tilted right here, and the equator is also going straight down in the middle. Okay? So the word rotation, think of it like as y'all were doing in math class the other day in advisory. Rotation is spinning on its axis. And as you can tell, that is counterclockwise. This is what causes the day and night, like I said before. So it makes one spin in 24 hours. It spins all the way around, making it day and night. So when we have the sun, okay, that's day, and then it spins and it turns around, and now we have nighttime, and the other side of the world has daytime. And remember, it spins counterclockwise. Revolution. This is orbiting all the way around the sun. As you can see in the little picture right here, it takes about 1 year, 365 days, to make all the way around. Okay, revolution, so you're thinking all the way around. Revolution takes a lot longer than a rotation. Orbit. Orbit is in the elliptical motion. So think of an elliptical. It is kind of shaped like this, like an oval, a curved path followed by Earth as it moves around the sun. So an example here is we have an elliptical motion around the sun. All the planets do, and the word orbit just means in that motion. So the tilt, Earth's axis is tilted, as I said before, as you can see it right here. Here's the imaginary line right here. Is tilted at about 23 degrees, and it always points to the North Star, and the North Star is called Polaris. So whichever way the North Star is, that's the way it's pointed. Okay? And in some diagrams, as you can see, it's pointed this way. It may be pointed the other way in a different diagram. As the Earth moves around the sun, the axis always is pointing in the same direction. So right here, you can see it's pointed this direction. Once it moves around the sun, it's not going to change the direction that the axis is pointing to, because remember, it always points to Polaris, which is the North Star. This means that during part of the year, the northern part of the Earth will lean more directly to the sun, and the southern part will not be directly towards the sun. So sometimes the way that, if you look here at this picture, the northern hemisphere is pointed more towards the sun than the southern hemisphere. So that's where we get our seasons. And on this side, the northern part is away from the sun, and the southern part is getting more of the sunlight. So if you can think about it, that's how we're going to get different seasons. Summer, winter, fall, spring, all those different seasons. It's because of the way the Earth is tilted and moving around the sun. So the energy that hits the Earth changes over time. The angle the sun is above the horizon determines how much heat and light strikes each square meter on the ground. So sometimes it's going to be hitting it directly, so you're going to have more energy, and sometimes it's going to be hitting indirectly, the sun will, and the energy will be less. In the winter, the sun's energy is weakened because the sun's rays strike the ground indirectly. So that's whenever we're not going to get as much sunlight versus direct sunlight. So during summer, we are going to be getting direct sunlight straight onto the ground. So that's why it's hotter. The temperatures are rising. More energy is received by the ground during the summer, like I just said, higher temperatures, and less energy during the winter. That has to do with direct sunlight versus indirect. So during summer, we're going to be getting direct sunlight, and during the winter, we're going to be getting indirect. During fall and spring, the sun is hitting right on the equator, so right in the middle of the earth. The northern and the southern hemispheres are going to be getting indirect sunlight. That's why the temperatures are kind of mild. They're in between. So the equator is going to be experiencing the hottest temperatures, and the northern and the southern hemisphere are going to be getting indirect sunlight. So in conclusion, the seasons, this is the big idea, are caused by the tilt of Earth's axis and the revolution around the sun. So remember, the tilt is 23 degrees. However, if the Earth was not tilted, then we would not have seasons. And the revolution around the sun, so making that one whole trip in 1 year around the sun, that causes us to have seasons. The Earth's seasons are not caused by the differences in distance from the sun throughout the year. So a lot of people think it's, oh, during summer we're closer to the sun. That's not true. During the summer we experience more direct sunlight, and so that is why we are experiencing hotter temperatures. And during winter we experience indirect sunlight. That's why we experience colder temperatures. So it does not have anything to do with the distance from the sun. The northern and the southern hemispheres experience opposite seasons. So what that means is, if we are experiencing right now winter, that means the southern hemisphere is experiencing summer. When we experience spring coming up, the southern hemisphere is experiencing fall. When we experience summer, like in June and July, the southern hemisphere is experiencing winter. When we have fall, like coming back to school, someone else is, the southern hemisphere is experiencing spring. So look at this diagram closely. So if you look at this picture right here, here's winter. We live in the northern hemisphere. So up here, you can tell that our hemisphere is facing away from the sun. So if it's facing away from the sun, that means it's going to be colder. So right here, this is going to be winter. Okay, and as we are revolving around the sun, we will eventually get over here. Okay, in spring, we are going to be experiencing indirect sunlight. The sun will hit the equator, so we will be experiencing indirect sunlight. And as we move even further and further, see, the northern hemisphere is now facing the sun. So now we are experiencing summer. And as we're moving over here, the equator is now hitting again. The sun is hitting the equator, so we are going to be getting fall. And the process continues. So if we, coming back over here, if we're in winter, that means down here, they're in summer. Do you see how they're facing the sun? Okay. If we are in spring, they are in fall. We are in summer, they are in, the southern hemisphere is in winter. And if we are in fall, the southern hemisphere is in spring. Okay. Here is another diagram, but as you can tell, the axis is tilted in the other direction. So it's the same process, but you just have to look for winter and summer. If you can find winter and summer, you can do the rest. So if I look right here in the northern hemisphere, it is facing towards the sun. It's a huge clue that this is summer. Okay, and I'm moving counterclockwise. So after summer comes fall. So this is now fall. Coming over here. We are facing away from the sun. So therefore, this is now winter. And moving away, coming again, this is now spring. Okay, and it's just the opposite for the southern hemisphere. Here is just another example, okay, and it just has the months instead. So right here, we're facing the sun, so that has to be July. That's summer for us. So if we're in summer, the southern hemisphere is in winter. Moving this way. So after summer comes fall. They are in spring. Okay, this is in September and October for the months. And we move over here. During December, we are in winter, right? And they are facing the sun. So they're getting direct sunlight. They are in summer. We move over here. The sun is hitting the equator. And we are now in spring, and the southern hemisphere is in fall.